Hi everyone, so today we will be solving LeetCode 2125. It's called number of laser beams in a bank. So in this question, we are given a binary string array bank representing the floor plan of the bank, which is nothing but an m cross n 2D matrix. And each row, that is bank of I, represents the ith row consisting of zeros and ones, where zero means the cell is empty and one means the cell has a security device. So, and there is one laser beam between any two security devices if both of these conditions are met. So, the first condition is the two devices should be in different rows. Suppose we had two rows R1 and R2, and R1 had one device and uh, R1 had suppose two devices and R2 had three devices. So, the first condition says that beam can go from two devices between beam can exist between two devices if they are on different rows like this. You cannot have a beam from this D to this D because both of these devices are in the same row. So this is our first condition. And second condition says that for each row I, which is between R1 and R2, there are no security devices in the ith row. This means that suppose we had R1 and R2, and in middle we have a ith row. And suppose we are told that there are beams between R1 and R2. That is, beam is from this D to this D and this D to this D. So this is only possible if the middle row has no devices in between. Had it been the opposite case, suppose we had ith row suppose also had one device, then the case scenario would be different. In this case, R1 and R2 cannot have beams between them. Since the between row has also a device, so beam would first go here, and then from this D it goes to here. So this is our second condition. So both of these conditions should be met. So we need to return the total number of laser beams in the bank. So let me show you the diagrammatic representation also. So we have something like this. So the ones where we had ones, we had devices. So I have placed them in the matrix. And zero means empty cells. So here, as you can see, we have four rows, R1, R2, R3, and R4. So we would every time we would take a pair and consider a pair every time to calculate our rows, number of beams, sorry. Suppose we had initially a count of zero. This would keep a track of how many beams we have encountered till now. So first we consider this pair. So here, as you can see, R2 has zero devices. There are no devices here. And we all know that if there are no devices, beam cannot go from R1 to R2 because beams exist only between devices and that too from different rows. So R1 and R2 pair is skipped. So next pair is R1 and R3. Now R1 and R3 pair both have non-zero number of devices. So in this case, beams definitely would exist between them. We are sure about that. So the beam can go from this D to these two D. Similarly, from this D to these two D and this D to these two D. So resulting in in six beams. So we update the count to six. Then we consider this R3 and R4 pair. Here also both the rows have non-zero, that is greater than zero devices. So beams would definitely exist between R3 and R4. And number of beams would be from here, it can go here, and from this D, it can go to this D. So we got two new beams. So count becomes plus 2, which is 8. So this would be our answer. So let's look at the further clarifications so that you can get more detailing about this. And now I've written the same test case again, and I've drawn the matrix as well. So see, we are considering pairs every time, right? So let's suppose take this scenario first. So suppose our R1 had one device and R2 has four devices in this case. So both are not, 0. They are greater than 0. So we are sure that beams would definitely exist between them. And here you can see this D1 in R1 has four options. It can either form a beam with D2, D3, D4, or D5. So D1 has four options, and 4 is nothing but the number of devices in the lower row, sorry. So 4 is nothing but number of devices in R2. Had it been 5 devices in R2, then D1 would have 5 options. So there would be 5 beams. So number of devices in bottom row. Now similarly here, as you can see, now here D1 has four options. It can go to D3, D4, D5, or D6. And similarly, D2 also has four options. It can go to D3, D4, D5, or D6. So here you can see, so what I'm trying to say is, suppose R1, there are two rows, R1, R2. R1 has one device only, and R2 has, suppose, n number of devices. This is D1, D2, similarly Dn devices are there. So if R1 has only one device, so that device would have n number of options, right? So n number of beams would be formed. So in this case, we would get n beams. So this was case when R1 had one device. But suppose if we generalize our case, suppose R1 also has, suppose let's say m devices, and R2 has n devices. So let's say D1, D2 dot dm, and D1, D2 dot dn. So in this case, see, one, if it was one, it had n options. Now it's m, so it would be m into n options total. That is, m into n total beams would be there by unitary method. So this was the main crux of the problem. Every device in R1 had n number of options. N is nothing but the number of devices in the lower row. So if there one device had n options. So if we had m devices, each one would have n options. So total number of options is m into n, which is nothing but a number of beams. So this was the main crux of the problem. So let me, explain you further about this to give you more clarity. Now suppose we have this scenario. So here you can see, as I told you, we consider a pair every time. So we would first consider this pair. We would take a variable current which points to the current row. Not points to the current row, rather it would keep track of how many devices are present in current row. So, and we would also keep a variable previous. It will contain number of devices in previous row, because at the end we need to multiply it, right? As we saw in the previous discussion, the number of devices in previous row. So, and previous, suppose since we are starting current from our first row, so first row's previous is nothing since we have no rows above it. So previous is initially set 0. So current, first we consider, even this also we don't consider. First we consider an arbitrary pair, which is this, because previous is initially 0. So we also take a count variable, which is initially set to 0. It will count how many beams are there. So we go to the current, we check how many devices are there. So we see that there are two devices. And we also see our previous has 0. That is, in the previous row, we had no devices. So number of beams, as I told you, is nothing but previous into current. That is number of devices in R1 into number of devices in R2, as I showed you earlier. R1 or R2 are nothing but adjacent rows. So previous was 0 and current here is 2, as I told you. So 0 into 2 is nothing but 0. So count still remains 0. So we have considered this. Now we consider this pair, that is R1 and R2. Now our current moves here. And before moving to this, now our previous will become this, right? Because for this as current, its previous is R1. So now previous is reset to the current, that is this current, which was 2. So now previous is 2. So every time when we change our current value, first we assign the current value to previous so that we can retain that thing. It's because we need the previous data. Then only we can multiply, right? So previous was set to 2 because we had two devices in a previous row. And this is a previous row because this has now become our current row. So now we count devices in our current row. We can see current row is R2 and it has no devices, zero devices. So that's why current is 0. So again we do the multiplication. Previous into current is 2 into 0, which is nothing but again 0. So still 0 is added. So we again have 0 only till now. Now this is the interesting thing. Now next pair is this R2 and R3. So now you may wonder that we would now make the previous to 0 because it was the current. Before updating the current to this, we would change the previous to this current value, that is 0. But we would not do in this case because, see, I told you, right, that beams exist only between two rows which have non-zero devices. But this is a row which has 0 devices. So beams cannot come here, right? Because it doesn't even have a single device. So for this as current, we are not concerned with this row anymore because this is doesn't even have a single device. So no beams would come from that, right? Rather, beams would come from this R1, as I am showing in this using these arrows. Even though it's not just the above row of R3, but still R1 beams will come from R1 because the middle row had 0 devices. This was our second condition, if you remember. So that's why if we would every time check if our current row has 0 devices, then we would not reset our previous. Then we would not change our previous. So previous in this case remains 2 and it not becomes our current at the 0. So I hope it's clear. So previous still stays as the number of devices in this one because R2 had 0 devices. So for R3, previous would not be R2, but it would be R1 only because R2 has 0 devices. So no beams can from there. So I hope it's clear. So previous still stays as 2 and current is nothing but now current is this. So number of devices in this is 3. So current is 3. Now we have again performed the multiplication. Previous into current is 6. So we add 6 into our count and eventually we return this as our output. So I hope this is clear. Now let's come to the code of it. So I've written the code of it. So we return the number of beams, that is an integer value, and we have a string array banks, which has binary strings. Initially, I have taken beams variable to count the number of beams. In dry run, I took count. Here I'm taking beams. You can take any. You can name it any way you want. And also previous is initially set to 0. So we process each string from our bank's 2D matrix. We compute its length and current is initially set to 0. This will count how many devices are there in a current string. So we traverse our current string in this loop and we check if it's a 1, that means it is a security device because 1 denotes a security device, right? So if it's a 1, we increase the current count. This current count, denotes how many devices are there in current row. So this counts them, and at the while after processing the row, we check, as I told you, if our current row had zero, devices. Like in the previous case, we had R2 had zero devices. So in that case, we would not make our previous into current. This is only done when current devices is not zero, as you can see here. So that's why I put this check. If it's not zero, then only we will do this thing. And also we count the number of beans, which is nothing but previous into current. That is the simple multiplication. This I could also have written in outside this if the reason for this is because, see, if current is zero, eventually the multiplication would also become zero, right? So that's why it's not, it doesn't make sense to calculate this quantity. If current is itself zero, then multiplication would definitely be zero only. So that's why you only do the addition in the beams variable when current is not equal to zero. And at the end, we return our beams value, which will be storing the number of beams in the bank. So this was the code of it. Coming to the time and space complexity. Since we will traverse every element of our matrix and our matrix dimensions were m cross n, so time complexity becomes m cross n. Since we need to access every element of our matrix. And coming to space complexity, we are using just a couple of variables, which is negligible space. So space complexity is constant, that is big of 1. So this was the time and space complexity of our code. So I hope the question is clear. So I would be making similar content. And if you like the video, kindly drop your comments, like the video, and make sure to hit the subscribe button. So yeah, this was it for today's video. Thank you so much for watching.